Okay, so everybody seen the screen also and audible? I'm audible. Hello, everybody seen my screen? Hello.
Yes, sir.
Okay, so we will start the session. Today's session is for the instructions are there. So last 2 to 3 lectures we were discussing the instructions of the 8051. So this is the last part of the instruction is programming branching instruction is there. Okay, this is the program branching instruction are there. There are the group instruction. These are the instructions which are giving the branch instruction is there means you have to move the cursor to the any locations by using these instructions are there. So at the time of the program also we discuss the instructions, how to use this or how to use the instruction in the program is there. So these are the L jump, A jump, H jump. These are the instructions are there. Z, jump if zero, jump if not zero, compare, jump if not equal is there, decrement, jump if not zero, no operation is there, long call or L call is there, absolute call is there, RET return instruction are there, RETI return interrupt, I means interrupt is there, and jump is the jump instruction is there. So one by one you discuss these instructions. So all these instructions except NOP. NOP is that there is no effect on the program is there. No operation means what? Program will stop the operations are there. So this is NOP is there. Okay. So one by one discuss the A call instruction is there. This is the A call instruction is there. A call instruction is called the absolute subroutine call. A call instruction is absolute subroutine call is there. Absolute subroutine call is there. ADR11 means what? It is a 11-bit address you have to give on to this. It is the 11-bit address given to this. It is the 2 byte instruction. It is a 2 byte instruction is there. Okay. Program counter is equal to stack pointer is there. Means you have to next 2 bytes you have to store into the stack pointer is there. And again address is stored to the program counter. This address is the 11-bit. Maximum 11-bit address you have to give on to the by using L call instruction is there. Another is a long L call means long subroutine call is there. L call means long subroutine call is there. So this is a 3 byte instruction is there. Program counter will store the PC plus 3 byte is there. Means what? This 1 byte is for the L call is there. You can say upcode of this L call is there. And this is 16-byte address. So you require a 2 byte is there. 88-byte 2 byte is required. This 16-byte you have to store into the program counter there. So it is due to that it is a 3 byte instruction is there. So I'm give the homework to that. What is the difference between A call and L call is there? So we'll discuss this. See, L call is a 3 byte instruction. See, L call is a 3 byte instructions. Then first byte is required for the opcode. Okay. Second and third byte is for the address of the target subroutine is there. Where you have to move the where we have to move the cursor. So this is the two 8 byte instrument 16 bit is there, sorry, 16-bit is there means 2 byte address is there. So this is the 2 byte address. So total L call is a 3 byte instruction is there. So what is the difference between L call and L call is there? L call is anywhere is within a 64 kilobyte memory. See, what is the memory of your 8051 is 64 kilobyte. So by using L call instruction you can move the cursor whole in 64 kilobyte memory address is there. Means you have to move the cursor to the 64 kilobyte memory is there. But in a call is the 2 byte instruction. A call is 2 byte instruction is there. Okay, which is a call is 2 byte instruction. Target is up to the C. It is within a 2k bytes is there. So it is 11-bit. 11-bit address is there. So up to 2 kilobyte address which is occupied to transfer the cursor to that location is there. To that location is there. So what is the difference between these two? Only difference between these two is that only the difference between these two is that the target address of L call is 64 kilobyte and target address of the A call is the 2 kilobyte. See what is difference between A call and L call. Anywhere you can use the L call and A call instruction. There is no restriction is there. But what is the exact difference? Same thing he has doing. Same memory location, same data, same memory. Same. It's occupy the same data in your memory is there. But what is the difference between these two? That this is also L call is a 3-byte instruction. First difference is L call is a 3-byte instruction. Okay, so 1 byte is for the opcode and 2 bytes are for the address is there. And A call is a not a 16-bit contain address of 11 bit is there, so it is a 2-byte instruction is there. Another thing is that in lcall you can occupy or you can move the cursor by using the instruction up to the 64 kilobyte. You can move the cursor up to the 64 kilobyte is there, but in a call you can occupy the memory or you can move the cursor up to the 2 kilobyte memory is there, not more than that. Means limitations of these two, a call and l call is there. So you can where you can use anywhere in the L column. If you require more memory you to occupy is that occupy means what is the meaning of that? You can move the cursor to that location is there. Move the cursor of the two location is there. Means 000 to suppose 64 is the location, 64 location, 64 key locations are there. You can move the cursor in any location means that you can store the subroutine of any location and you want to call that subroutine from that locations, and for that purpose we have to use the L call is there. But your 2 kilobyte when you are required ins where up to the 2 kilobyte memory location is there. So this is the L call and this is the A call instead. This is the difference between L call and A call. So remember this, it is very important at the time of your oral examination, at the time of your online examination. So it is very important of the L call and A call. L means long call and A means absolute call. Both are used for the subroutines are there. Both are used for the subroutine. These are not used for your interrupts are there. They are used to the subroutine is there. So remember these things. After instruction is calling by this L call and A call, to return we have to require instructions RET. Means how can microcontroller understand that go to the next instruction is there. So for that purpose what we have to do, we are giving the rate instruction. Rate instruction is given after the completion of the subroutine is there. Then our cursor will be moved to the next location after where you have to call the instructions of the L call is there. So for that purpose we have to use the rate. So in maybe in online examination they ask the question where we have to use after L call and A call instruction, what instruction we use to go to the main program. So they give the option is RET and RETI. So you have to write down the instruction is RET, return is there, not return interrupt is there. Return interrupt is used for the interrupt is there. You know that what are the interrupts? 6.5, 7.5, 5.5 trap interrupts are there. So when you call these interrupts, then after that you have to transfer this interrupt 0, interrupt 1. You have to transfer the interrupt track interrupts are the interrupts 8085, 8051 is the and interrupt 0, interrupt 1s are the interrupts are there. So you have to call the interrupts is there. So we have to use the RETI instruction is there. So remember this thing, this is the difference L call and L call is there. The next instruction is return. I am discussing return instruction here. This is the instructions return instruction return. You know that return instruction is from the subroutine. Remember these things. Return instruction is from the subroutine is there. When we have to use the L call and A call instructions are there, so you have to call the subroutine is there. Then after subroutine, you have to use the completion of the instruction in the subroutine. We have to use return program to return from subroutine, not to from subroutine. You have to go to the so stack pointer value is transferred to the program counter. Understood? Here, see, in L call is there program counter value is transferred to the stack pointer. See, here A call and L call you have to program counter value is transferred to stack pointer is there, and after return instruction, this stack pointer value will be transferred to the program counter is there. This stack pointer value will be transferred to the program counter. This is 1-byte instruction is there. Again, RETI. RETI is return from the interrupt is there. Return from the interrupt is there. By interrupt, in interrupt, if you write any programs, in interrupt you have to write any program is there, and you have to come from that interrupt to the main program. You have to use the RETI instruction is there. So return interrupt. I means interrupt is there. Again, it is a 1-byte instruction. Again, it is a 1 byte instruction is there. So a call is address is 11 byte, L call address is the 16 byte. So it is used for the 2K, it is used for the 2K, and it is used for the our 64K is there. It is our 64K is there. Okay. The next instructions are A jump instruction, L jump instruction, and H jump instruction. Okay. See here. A jump is absolute jump, just like a call, it is a jump is there. Just like a call, it is a jump is. A call and S call is used for where we have to use here used for the call the subroutine is there. But jump is called within the program if you want to move the cursor within the program or within a upper location of the program or lower location of the program, or depending upon the condition of the program, you have to transfer the program counter to any locations. For that purpose, you have to the jump instructions are there. Okay, so jump instructions are absolute jump, long jump, and short jump are there. Absolute jump, long jump, and short jump is there. So absolute jump is what you have to use. It is a 2 byte instruction. Absolute jump is a 2 byte instruction. A jump is the one opcode is there. A jump is the one opcode is there, and address is the 8 byte is there. So it is means 11 byte is a 2 byte instruction is there. In a long jump, you have to use the address. The 16 bit is there, and long jump is there. So it is a 3 bit instruction is there. Sorry, 3 byte instruction is there. So because address require the 2 byte is there, and for opcode long jump you have to use the 1 byte is there. Just like our L call is there. And this is short jump. Short jump is also a 2 byte is there. Short jump is also 2 byte is there. Okay, understood. See the difference here. Absolute jump is there. You have to transfer the address to the program counter. Here also long jump you have to transfer the address to the program counter, and here you have to transfer the edge jump is program counter plus 2 plus this is the location where you have transfer this transfer to the program counter is there. See in previous session what we have to all the program counter address is transferred to the stack pointer, because by using subroutine you have transfer the program counter to the where subroutine is the located is there. So all the program counter values, program counter location is transferred means next program counter location is transferred to the stack pointer is there. But in your agm there is no stack pointer we have to use. We have to transfer the cursor, or you have to transfer the program counter within a program is there. See the difference within the program you have to transfer this. So only you have to transfer the address to the program counter is there. You have to transfer the address to the program counter is there. There is no need to transfer the next address to the stack pointer is there. So this is difference between jump and call instruction is there. Okay, so here it is a 2 byte instruction, it is a 3 byte instruction, it is a 2 byte instruction. So what is the difference between this? I am giving the homework to all of you to see the difference between a jump, L jump, and H jump is there. So I am writing here, just see this. H jump, L jump, and absolute jump is there. H jump, L jump, and H jump is a short jump. Okay, see, it is a short jump. It is related to the 8-bit. Remember this, it is related to the 8-bit is there, and it supports a 127 locations only. It is supports 127 locations only, not more than 127 location. It is the transport. Here long jump, just like our L call is there, it is a 64 kilobyte is there, 64 KB location. It will be location where you have to forward the cursor is there. In absolute jump is your back to it is up to the 2K is there. It is up to the 2K there. So absolute jump is up to the 2K. In your absolute call also it is a 2K is there. It is a 2K is there. Okay, then edge jump, it is remember these things. Edge jump 8-bit, L jump 64 bit, A jump is a 2K. So for your within the program, just like jump if not 0, jump if not carry, JB. These are instructions are like a short jump instructions are there. These are the not long jump, these are short jump instruction are there, because they are within the program. You have to move the cursor is there. So up to the 127 location is sufficient to transfer the program counter to that position is there where this is to where this instruction will be shown. So this is a HM. So all these instructions are the HM instruction are there. Next, see, it is a 8-bit address. It is 8-bit address. It is 16-bit address, and it is a 11-bit address is there. Okay, similar. to that, it is 2 byte instruction. Lcall is long jump is 3 byte, and again absolute jump is the 2 byte instruction is there. Okay, you see the conditional branch instructions can be used. Relative jump cannot be used. Long jump is, long jump is there, cannot be used for the absolute jump is there. Okay, so address calculation, program counter is equal to the 11 bit, program counter equal to the, sorry, it is not a program counter here, it transfer it to the 16 bit here, and 11 bit is here is there. Okay, so here is a 16 bit, sorry, by mistake this is, it is a 16 bit, and it is a 11 bit is there, it is a 11 bit. So this is the difference between only see that एकच लक्षात ठेवा difference. What is the difference is there? A jump is 8 bit and it is 127 location. For long jump only 64 kilobyte location, and A jump is 2 kilobyte. So how the programmer, where, how can you say that the program is a good programmer? How can you say that the programmer is a good programmer? So you have the, in your C programming also you have 3 loops are there. Do while loop is there, for loop is there, and while loop is there. Same program, suppose I want to do the addition of first 10 numbers. If you want to do the program is addition of first 10 numbers, you can use while loop also, you can by using for loop also, or you can by using do while loop also. These 3 loops, by using these 3 loop syntax, or by using these 3 loops, you can add the first 10 numbers. So which loop is good for your programming purpose? Then which loop? Do while loop is good, for loop is do, loop while loop is good. So by using that, where which loop is good, by using, you have to use that loop, then your program will be good. What is the aim of the programmer is? Aim of the programmer is, first is that iteration should be less. If it is 10 iteration, you can use such a loop is that you have to give the 9 iteration is there, but answer is the same is there. So if less iteration are there, your program speed will be increases there. This is the one part is there. Another part is that your size of the program should be, your make a size of the program should be less is there. So where we have to use, suppose if I'm using the ljump instruction, we require the 3 bytes to store is there. If I'm use the sjump instruction, we require the 2 bytes are there. Suppose same program you can done by using sjump. If your same program you have to by sjump, and if you are using the ljump for that, then you're not a good programmer, because you are wasting 1 byte of my 8051 is there, you're wasting 1 byte of my 8051 is there, understood? But if you are using the sjump about that program, then you can save my 1 byte is there, so you are a good programmer is there. So by using practice, you can understand which jump is where to use. So what is your aim is there, you must decide what is your aim is there. You have to increase the speed of your program, and another aim is that you have to make to less storage of the space. You have to make less storage space to store the program there. If programs space is more, then your execution speed will be less is there. So remember these things, because we are doing the small programs, there is no effect of the execution of the program. You can don't understand the speed of the program, because whole program will require a fraction of second to run the program. But you are doing the more lines of program, then these things should be a matrix there. These things should be a matrix there, where we have to use the for loop, where we have to use the while loop, where we have to require the do while loop. Same thing where you have to use edge jump, where we have to l jump, where we have to a jump is there. So by using these things, you have to understand the you can increase the writing of the program skill of your is there. You can increase the writing skill. Okay, so these are the instruction size you must be remember after working with the programmer. Big programmer is there, so you must remember this size of the byte instruction, because by using that your program size, because you know that your program size up to the 2k is there. So if you write a program more than 2k, we require the external rom is there to store the program is there. So these are the instructions of jump instructions are there. So remember these instructions. So L call, A call, return, RETI, A jump, L jump, A jump. Because when you go to the oral examination, every person, every external must ask the question, what is the difference between A call and L call? What is the difference between A jump, L jump, and A jump? If you give the answer good, then you can think that no, you know the all the instructions of the 8051 there. So remember these 5 instructions are there, and RET and RET. Next instruction is jump. So this is the jump at the rate a plus dptr is there. A plus dptr is transferred to the program counter. It is 1 byte instruction there. So a plus dptr means what? Just I'm giving. There is some sound from outside is there. Okay. So this the instruction is it? Jump at the rate a plus dptr. Okay, this the instruction is there. Jmp is there. So this the instruction is there. Jump instruction, jump at the rate a plus dptr. Okay, so a at the rate means you can understand the location where you have to store the data. It is it plus of these two is there. Okay, means suppose a is 8 byte. Suppose a is contain 05 or 01, you can say 01, and if your dptr is store 2000. Okay, if you add these two, what is the location is 2001 is there. Okay, it's 01 and dptr is 2000 is there. 2001 is the address is there. So this is the address a plus dptr is there. This is the a plus dptr is the address is there, means what, 2001 is the address, and at that 2001 if there is a some value, you can say suppose 45, there is some value is the 45, and at that 45 location you have to jump the data is there. So you have to jump the cursor is there. So this is a jump instruction is there. So this is a jump instruction is there. So this is the jump instruction. The jump at the rate dptr plus a plus dptr is there. So a means the accumulator is contains some value, dptr is data pointer is a 16 bit. You have to add these two, there's will come some values there. This value is the location. At that location there is some value where you transfer the cursor is there. Okay, then jump 0. Jump 0 means what, if jump 0, this is the instruction jump 0. Jump 0 means what, if your accumulator is 0, if your accumulator is 0 means that you have to jump to the location which is given by our pcl. Rel means what, you have to give the, suppose I am giving the, what I am giving the label is giving, suppose up label I am giving up label, up up is there. So if your accumulator is 0, if your accumulator is 0, then you will be cursor is moved to the up. Up is the label where you have to move the cursor is there. So this is the up level is there. If a is 0, jump to the up is there. This is 2 byte instruction. Then next is the jump if not 0. Jump if not 0 means if your accumulator is not 0. If you have accumulator is not 0 means what, the accumulators contain some value, then your cursor will move to the instruction is the where the label is given, maybe up label is given or maybe any label they are given is there. So this is the instruction is there. Jump if 0, jump if not 0. These instructions are related to your accumulator is there. These instructions are related to your accumulator is there. Okay, then this is the instruction is compare jump if not equal not equal, compare the jump if not equal is there. A is the accumulator, then this direct means the location we are giving, hash data means direct data you have to given, rn means a value register is the value and the data is rn, then location at where the value is stored, and rel is there. Okay, so what is meant by the compare? What is the meaning of the compare if not equal is there? What is the meaning of compare if not equal is there? See, compare jump if not equal. Compare jump if not equal. There the instruction they are giving a is the accumulator and they are given directly value is 20. I'm going writing 20h is there. Okay, 20h is there. Okay, so how this instruction work? how this instruction is work is there. Suppose your, and then again there is a comma up. बरोबर है ना? Same instruction is there. Okay. REL means give the label is there. REL means give the label is there. REL means give the label is there. So jump is up. Here is the up is there. This is the label, and here is the instructions are there. Okay. So these are the instructions are there. Okay. So what is the meaning of this compare? Compare a comma 20. If I'm asking you, if I'm asking, it is number 21 is there and another number is 12. So by compare these two numbers, these are equal. Okay, these two numbers are not equal. If I am seeing which one is bigger than this number, so how can you how can you give that? How can you say that? Then what calculation you are do in your mind is that you say that 21 is the larger number and 12 is the smaller number. How can you give the answer is such that the 12 is the 21 is the, so you can say 1 to 12, first comes 12, then 21 will be after 12, so 21 is the bigger than the 12 is there. If I am giving such a number is there, suppose, when I'm asking what is the big number is there, what is, which one is the big number is there, so required a lot of time to give the answer is there. So compare means what they are doing. The compare means what controller is doing. If I am giving the comparison, what controller is doing. See if I am giving same example, 21 and 12 is there, so what he is doing, which number is greater or these two numbers are equal or not. Suppose accumulators contain a accumulators contain a 20 also. Okay, accumulators contain 20 and our the number is given by this is a 20 is there. If these two are equal, if these two are equal, then cursor will be not go to the up instruction, this will become to the this instruction. This is another instruction after the compare jump is there. When these two numbers are same, means accumulator is contain value is 20 and our hash means the value which is the 20 are the same value, so it will go to the next instruction is there. But suppose your accumulator is a 12 value, accumulator is 12 value, and your hash 20h is the number which are directly given, which data is given, then compare these two. After comparison, he think that there is a no equality there. So how can you understand no equality there? What he is doing, control is doing subtraction. Control is doing a subtraction. What is doing subtraction? 12 minus 20. It do the subtraction is the 12 minus 20 is there. 12 minus 20 is there. So 12 minus 20, then if there is no equality because the answer is not 0. If you subtract these two, the answer is not 0, the answer is 8 is there. So working with the decimal is there, so your answer is the 8, so that our cursor will move to the up is there, our cursor will move to the up is there. Okay, you can understand that the cursor will move to up because 12 and 20 are not the same numbers are there, not equal numbers are there, so you have to, but if anybody says, if any ask which number is big number, which number is big number by using this instruction, can you find the big number is there? So for that purpose, see, if you 12 minus 20 is there, which is the bigger number? 20 is the big number is there, 20 is the big number is there, so that due to that the carry flag will be generated. Carry flag means you can say a borrow flag, because if you are giving the 12 minus 20, then carry flag or borrow flag will be generated. There is no borrow flag present in our 8051. There is a carry flag generator, c is equal to 1. It will generate a c is equal to 1. Then you can say that this 12 means accumulator number is less than the number which is given 20h is there. Okay, understood my calculation thinking, understood the control is what control is doing. Control is doing subtract the second number from the accumulator or subtract the number from the accumulator is there, so that if carry generated, carry means what, in your subtraction you can say the borrow is there, in subtraction you can say the borrow is there, means your answer or your calculation purpose you can see your answer is negative. Your answer is negative because after the 12 minus 8 your answer is minus 8 is there. Okay, your answer is minus 8 by using your decimal. Subtraction is there. Negative sign of your second number, which is the big number, is there. So that the minus 8 is the value is there. So 12 minus 12 is greater than, sorry, 12 is less than 20 is there. So that your carry flag is generated. You know that where is the carry flag? Carry flag is stored into the program status word. So if you check the carry flag in your programming, if you check the carry flag after this compare instruction, if carry flag will be 0, then you can directly say that accumulator value is less than the value which is given by the, which is value directly hash 20h is there. Okay, understood. And if our carry flag is 0, if our carry flag is 0, then your accumulator number is more than, or accumulator value is more than that of the 20. Means suppose here is I am giving the 32 is there. If I am giving the 32 is accumulator contain 32, so 32 minus 20, you will get the answer is the 18 is there. Okay, sorry, not 18, 2 is it, 12 is there. Your answer is the 12 is there. Answer is the 12 is there. Here answer is positive. Okay, here answer is positive because first number is bigger than the second number. So in your controller thinking or controller word, your carry flag will be 0 is there. So when you are giving the instruction compare jump, and if you check the carry flag, if you check the carry flag, if carry flag is 0, then your accumulator number is more than that of the 20, the number given 20h is there. And if carry flag is 1, then accumulated number is yes. You can write the instruction are given like this also. Compare CJNE, compare A comma R0 also. Okay, you can write like this. They are giving the again here directly you are giving the accumulate here indirectly, here is directly data is given, and by using the data also, here data, here register and data is there, here accumulate and data is there, and here is the at rate. So here you have to subtract rn minus data. The first number, your my first value, upcode value, first value of this instruction minus the second value which is given to that is there. So these are the compare. These are very important instruction. Compare jump if not equal is there. We require a lot of time. These instructions are there. Compare jump not equal is there. In that instruction, he is doing comparing the two numbers. What is meant by the compare the numbers? If you are compare anything, you can compare with the others. What you are thinking? You are thinking that you're doing the uh, minus means subtraction of these two numbers. Compare means what? You have to subtract the these two numbers are there. You have to subtract the these two numbers, and you have to see the value of the carry flag. Then you have to decide the number is equal, or which number is bigger than, or which number is the smaller than. So this is very important instruction of compare jump if not equal is there. Okay, this is a 3-byte instruction is there. This is a 3-byte instruction. This is 3-byte instruction. All are the 3-byte instruction. Then next is the instruction is decrement rn and jump to the pc plus rl if not 0. म्हणजे jnz म्हणजे काय? जम्प इफ नॉट 0. जम्प इफ नॉट 0 आणि काय करायचं? डिक्रीमेंट करायचं. यू आर डुईंग द डिक्रीमेंट अँड जम्प इफ नॉट 0 इज डिक्रीमेंट ऑफ व्हॉट? You have to decrement the register rn. You have to decrement the register rn and check that the register rn is contain value 0 or other than 0 value is there. If rn is contain a 0 value or other than 0 value is there. If it is other than 0 value, the value of rn is not 0, you have to jump the instruction, jump the program counter or jump the program location to the rel. Rel is the label where you have to transfer the data is there. Okay, see what is the instruction is there? Decrement jump if not 0. Decrement if jump if not 0 is there. Decrement jump if not 0 is there. Okay, so what are the instruction they are giving? rn comma rn comma rl is there. So the label is there. These are the label is there. So Rn up is there. Rn means not I'm directly like an R0 is there. Register is there. So there is up value is there. Okay. So what is the meaning of decrement jump if not zero? Means suppose your R0, suppose your R0 is contain R0 is contain a value of 10 is there. Suppose R0 is contain a value of 10 is there. Decrement R0, it will go to the 9, then go to the 8, go to the 8, 9, then go to the 8, then 7, then 6, then 5, then 4 up to the 0. So first it decrement the R0, means it decrement the value of the R0 to the 10 to the 9 is there, and jump if not equal to 0 means he check the value of the R0 is there. If R0 is not equal to 0, then go to the up is there. If R0 is not equal to 0, then go to the up is there. And if R0 equal to 0, if R0 is equal to 0, then it will go to the next line after this instruction. Means when R0 is goes to the means after some time, after 10 iteration, the value of Rn will be R0 is equal to 0. So it does not go to the up, it will go to the next instruction after the decrement jump if not 0 is there. After that you have to go to the decrement jump if not 0 is there. So this is the instruction of decrement jump if not. So first see D means first decrement. First he decrement the R0. Remember this. First he decrement the R0 and then check the value of the R0. It is not first check the value of the R0. First he decrement the R0. R0 if suppose 10, he decrement to the 9 is there and then check the value of the R0 is 0 or 1 is there. So you must remember these things. Decrement is the first line is there. Next instruction is NOP means no operation is there, 1 byte instruction is there. Your control is not doing any operations is there when working with the is not working means no operation is there. It is stay in ideal state is there. Stay in ideal state is there. What he is doing previously is stop there means you have to give such a time you are giving the delay is there. No operation means you have to give the delay to the controller is there. This is NOP is there. Okay, so this is the rate instruction I am giving. See rate instruction we are discussing there. Rate means it is used to return from the subroutine called by lcall and lcall. Lcall and lcall, sorry, lcall and acall are the instruction which is called for the subroutine, which is used to call the subroutines are there. So by using return from the subroutine, we have to use return from the subroutine, we have to use the RET instructions are there. Return from the subroutine, we have to use the RET instructions are there, and RETI instruction is you have to use from the interrupts are there, where you have to use from the interrupts are there. So remember this, we are discussing this one, but here I am writing this instructions are RET and difference between R. So three difference we are discussing today: S jump, L jump, A jump, L call, A call are there. L call, A call, and S jump, L jump, and return and RETI is there. And one more instruction we are discussing: compare jump and decrement, and no operations are there. And these are the instructions are there. Okay. So next part is our programming, but we have only 10 minutes are there. Just I'm overview all the instructions, and from next lecture we will start to the assembly instruction format or assembly programming is there. Okay. So just overview of the instructions are there. Just 5 minutes I am giving, not more than that. Addressing also discussing, then go to the program. It's very easy. Those students are not present before, then they can understand is there. Then 5 minutes I am cover all these points. So first is the immediate addressing mode. First is the immediate addressing mode. Immediate addressing mode is what you have to use move directly data is there. You have to give the data is there. So it is called a which is called it is called the immediate addressing mode. It is called the immediate addressing mode is there. Next is the register addressing mode. We have to use the register is for your transfer the or transfer data A or R files there. Register is your transfer data A and R file. This is called register addressing mode is there. Next addressing mode is direct addressing mode, means you have to 47 or you can say a 56 is there. 47 or 56 is there. So here is the 56 is the location. At that location value is 3 is there. 56 a location, at that location 3 is the value is there, and this 3 value is transferred to the R0. This 3 value is transferred to the R0 is there. This 3 value is transferred to the R0 is there. Okay. So 56H is the location. At that location there is some values there. This some value is transferred to the 56. This is direct addressing mode is there. Then register addressing mode means here I am giving the register indirect addressing mode means at the rate. Remember at the rate means what? R1 is contain a value. At that value there is a, sorry, R1 is contain a value. This value is the location, and at that location there is a value which is you have to transfer to your accumulator is there, which is your transfer to the accumulator is there. So this is the rest indirect means what? At the rate means what? R1 is contained location. At that location is some value. You transfer this value to the next. Next is the index addressing mode. We are discussing index address mode. Here is the A is there. At the rate means you have to move with the C means code. A means accumulator plus repeater is data pointer. You have to add this. There is some location will come at that location. Location is having some value. This value transfer to the 8-bit. So every time you have to transfer the 8-bit data, not more than that. Remember that thing. Only you have to give the addresses are there, but not more than 8-bit you have to store, because there is no register to store the more than 8-bit data is there. These are the instruction set. We are discussing data transfer instructions. Move C and move X is there for the code, and your data transfer. Push and pop is there. Push means for the stack pointer, and then pop is the from retrieve the point. You have to increment the push, and it is decrement by using pop is there. Exchange means, this exchange means what? You have to exchange the whole data from accumulator, and the 10 is the location where data is stored is there. Means after executions here I'm giving, after the execution x a comma 10, a is contain value 5 and 20 is contain value 8. So a will be good to that 8 is there, and your R0 will be 5. Exchange the data is there. Okay. And it is the exchange after the execution. Here the exchange means you have to only exchange the lower bit, is lower nibble. You can say you have to only exchange lower nibble is there. 25 is the location, is 5 is the lower nibble, and 47 is a 7 is the lower nibble. You have to only exchange the labels are there. 7 and 5 is there. Here is a push and pop is there. When you push the instruction, stack pointer will be incremented. You have to pop the instruction, stack pointer will be decremented. You have to take the value from the stack is the push pop instruction. You have to put value or give the value to the stack, or you have to store the value to the stack. The stack pointer will be incremented is there. So we're discussing this in brief there. There is the arithmetic instruction are there. Add C, SUBB, increment, decrement, multiplication, division, and most important is the decimal adjustment accumulator is there. Decimal adjustment accumulator is there. For BCD addition or BCD addition, we have to use the decimal adjustment is there. So you have to convert the hex number into the decimal is there by using adjustment, but we required for the BCD addition is there. See what is the difference in add? You have to add the two numbers, but there is no, you have to add the carries there. Only add the two numbers are there. If carry is present before the addition, it will not use the carry for the addition, but add C is add with the carry, means add the two numbers also if there is a carry. Where carry? Your carry is present in your program status word is there. So carry is present on that, and the two numbers you have to add these three numbers, and then you will get the answer. The SUBB, there is no instruction in your 8051 SUB. There is no instruction in 8051 SUB, direct SUB borrow is there. So in that instruction, you have to subtract the two numbers are there. SUBB is there. Okay. SUBB is you have to subtract the two numbers is there by using a borrow. Increment means you have to increment the value by 1, or decrement you have to decrement the value 1. There is no any facility to increment the two value, because if you are giving in your C program A is equal to A plus 5, B is equal to B 6, you can directly increment the 6, but here it is already increment by 1 is there. Increment by 1 is there. Means any accumulator is contain value, you have to increment it by 1 only, decremented by 1. Multiplication means you have to multiply the two numbers. For that purpose, you have to use the two registers are there, A and B registers. So for the division purpose also you have to use the two registers which are the A and B. So you know that where you have to store the quotient, where you have to store the remainder, where is you store the higher byte of your multiplication, and where you have to store the lower byte of the multiplication. You have to and this is decimal for the decimal adjustment design. You are discussing all these instructions are there. Decimal BCD addition we are giving. Then this is the logical instruction there. Here is the ending instruction and the two numbers. Then OR means or table or to table of the gate is there. Then XOR to table, clear all the data of the accumulator, complement the data of the accumulator. Then rotate left with carry, rotate right with carry, and swap is there. Okay, you know that rotate left means you have to go to the cursor to the from left to sorry right to left is there, and MSB will go to the LSB is there. And rotate right means you have to go from MSB to the LSB, and LSB becomes the MSB is there. Okay, you rotate left with carry, we have to use the carry also, and for rotate left with carry and rotate right with carry also we have to use the carry for the transfer the value. The rotate right means you have to use the carry here is there. Okay, we're discussing all the points in. Next, swap means what? You have to swap the data means suppose A is contain value of 87. Here is not a lower nibble, higher nibble transfer in accumulator itself is doing data swap means what? You have to move the lower nibble to the higher place and move the higher label to the lower place. Move the lower label to the higher place and higher label to the more place. Here the swap is there. Swap 87 and swap 78 is there. If it is value of 87 and then value of the 78 is there. Then these are the instruction. Clear, these are bit manipulation instruction are there. We are working with only bit is there. You have to clear one bit, you have to set one bit, you have to move one bit, you have to jump if carry, jump if not carry, then jump bit, they related to the jump bit, then jump bit. These are ANL, ORL, and XCPL there. So these are the bit instruction is there. Only the set one bit, complement one bit, ending one bit, O-ring one bit, move the one bit, jump if carry is set, if jump if not carry is with. Up to this is a bit manipulation instructions are there, and these three instructions related to the carry flag is there. JC jump if carry, jump if not carry, then jump if direct bit, jump if not direct bit is there. So these are the instructions we are discussing here. Clear the port to third bit, set the port to third bit. You have to move the carry to the accumulator 4 or ending, sorry, not move, ending the carry flag with the accumulators 4 bit is there. Then move the third bit of the accumulator to the two carry flag is there. Then here jump if bit means suppose this bit 2.3 bit port to third bit is having a values 1, then it will move the cursor to the location L1 is there. And if jump if not bit means if port 1.3 bit is not 1, if it bit is 0, then it will go to the L3, and if it is bit is 1, then it will not go to the L3 there. Then here is a jump bit 2.3 is there. So here is the port. After the execution, you can see this is 001 and 101 is there. So it will first jump the bit. If your port 2.0 bit means this last one bit is value is 1, it will move the cursor to the L1 is there. Before that, it will transfer this 1 to the 0 is there. So here we transfer the 1 to the 0 is there. Means jump bit if carry flag. Jump bit if clear, not carry, it is clear. Means if port 2.0 bit is 0, 1, then it will move to the L1 is there. But before moving, it will convert this 1 to the 0 is there. So this is the another instruction, and here today we are discussing these instructions are there. So these are the instructions for the 8051. I am discussing at most more all instructions there, and then we are go to the next part of this is the programming is there. Next part of this is the programming is there. Okay. Okay, if you have any difficulty, then ask me, because all instructions are completed. From next lecture we are go to the programming is there.